Let's go to page 213, and this is section 18.3. This is about the cubes and the boxes. So a cube, the most common one that you see of a cube is a die. Like when you a dice. When you play games, you use the dice a lot, and so those are cubes. Okay. So for cube, every side would be equal. So this would be like x. So length, width, and the height. Length, width, and height, they are all equal. So this is the cube. Okay. And all the faces have the equal area. Now, so this is the cube. And the box will have it. You can have any elongated or whatever different shape. Okay. So this is an example of a box. And so this is the face, and this is the edge, and this is the vertex. Okay. And there's a relationship between this thing over here. So the relationship between them, you can see it later on. So the number of vertices plus number of faces minus edges will equal to 2. Okay. And so you can see it from here. Example of that would be, so vertices at the corner. So they got 1, 2, 3, 4, 5, 6, 7, 8. So use this example. You got 8 plus faces would be 1, 2, 3, 4, 5, 6. Right? There are 6 faces. And edges, so 1, 2, 3, 4, and there are 4 over here and 4 on the bottom, to 12 equal to 2. So you can see that that is true, right? Okay, so this is the important formula when you deal with the relationship between the vertices and the faces and the edges. Okay. And this is from page 222, so we kind of jumped a little bit ahead. Okay, now let's go back to the cube and boxes. Okay, so let's go over example 18-3. Okay, so you have A, B, C, D, E, F, G, and H. And okay, so here's a midpoint. Okay. So in a cube, A, B, C, D, E, F, G, H, A, B, C, D is a face, and M is the midpoint of the edge, DE. Okay. If from BM, if AB equal to 4, you're looking for BM. So you're looking for this line over here. Okay. So if AB is 4, then AD will equal to 4, right? Because it's a square. And use your spatial triangle 4, 4. This would be, so DB will equal to 4 squared root of 2. And if the DE is 4, then this would be a 2 and a 2. So you end up with a triangle BDM. So you got 2 and you got 4 squared root of 2. Okay, so BM, this would be your X. Okay, use your Pythagorean theorem. So 2 squared plus 4 squared root of 2 squared equal to X squared. And then work it out. So you got 4 plus 1632 equal to X squared. So 36 equal to X squared. So X equal to 6. Okay, and that's it. Okay, let's go to example 18-4. Okay, so you have a cube with an edge of 6. I'm going to just divide that up already. Okay, anyway, you get the idea. Okay. So you cut it into 1 unit cubes. Okay, how many? So you're looking for. So now you paint at the outside. Okay, then you cut. So how many blocks have no face painted? Okay, so the no face painted would be the one on the inside. Okay, so let's go and do the one face. So all these will have a one face, the red ones. Okay. So one face painted will equal to 4 times 4 times, there are 6 faces, so times 6 faces. So this will equal to, so one face painted equal to 96. Okay. And then 2 faces. 2 faces painted. 2 faces painted would be the green one right over here. Okay, so on the corner over here. So this would be the 2, the green ones. Okay. Okay, so there are 1, 2, 3, 4. So there are 4 of them, and there are 12 edges, right? So 1, 2, 3, 4, 5, 6, 7, 8, and they're on the bottom. So times 12 edges, and so it gives you 48. Okay. And the 3 faces would be the one on the corner. So there would be just 1, 2, 3, 4, 5, 6, 7, 8. Okay. And if you're looking for the north face, okay, so north face painted. So that would be the inside. So there would be the one behind these red ones. Okay, so it would be 4 by 4 by 4, and so it would give you 64. Okay. Okay, let's go to example 18-5. Okay, so you have this picture given. And you have A, B, C, D, E, F, G, H. Okay, this is from the area of BDE. Okay, so you have B, D, E. Okay, so basically what you have is that AB equal to 6, so it means every side equal to 6. Okay, so that means the BD. So notice 6 and 6, right? So this would be 6 square root of 2. 6, 6, and so it would be 6 square root of 2, same thing. So basically you have an equilateral triangle. That's what you have. You got B, D, E with each side equal to 6 square root of 2. Okay. Okay, so the area will equal to 1/2 base times the height. Okay, so now do I have to figure out the height? So cut in half. So this would be 3 square root of 2, right? Half of that. And then you times by square root of 3, so it would be 3 square root of 6. Okay, so 1/2 base times height. And so K equal to cancel out. So, so this would equal to 9 square root of 2. I'm going to break this into square root of 2, square root of 3. Okay. And so this can come out, so K equal to 18 square root of 3. Okay, and that's it. So again, that's how you can do calculation without using calculator. Just break it down, and square root of 2 square root of 2 equal to 2 times 9 give you 18. Okay, let's go to next terminology. So on page 215, Okay, you have a right parallel pipette. So you have this term right over here. Okay, so right parallel pipette means box, means you have a box. A box is a parallel pipette. And when it says right, means it goes straight up, okay? Because sometimes a box can be slanted, so the front face can be a parallelogram, right? So that would be not, so it's not right. So again, when the word right means it goes straight up and down. So that means every face is a rectangle or a square, okay? And on page 215, it gives you, so you have a box. So you get length, width, and height. So the area would be just, so in this case, they use a small letter, so okay, length, width, and h. Okay, so front would be, okay, I'm gonna do all these. So the front face would be the base times height, would be LH, okay? And there are two of them because the front and the back. And the right side is the base times height, and you have the right side and the left side, so 2 times, right? Then the top, or the bottom is the length times width, and the top is the same, okay? So again, you have the front and the back, right side and the left, and top and the bottom. And from here, you can factor the 2, so it would be LH plus WH plus LW. Okay. And the volume would be just the length times width times height. Okay. Okay, let's go to example 18-6. It says find the volume of the box. So the volume equal to, find the volume of the box which have a diagonal length of 35 and 2 dimensions of 1 and 5. Okay, so two dimension would be 1 and 5, and the diagonal is square root of 35. Okay. So we can call this x over here. So the length of the diagonal is just a square root. See, when you are 2-dimensional, you use Pythagorean theorem, you get a squared plus b will give you c squared, right? But for 3-dimensional, you just have one additional element. Okay, so basically you have square root of 35 equal. So this diagonal equal to square root of x squared plus the 5 squared plus the 1 squared. Okay, so that's what you have. So square both sides. Okay, you get rid of the square root. So minus 26. So x squared equal to 9. And when you take the square root, because this is a physical object, normally when you take the square, you get plus or minus 3. But because it's a real object, so you only take the positive. So x equal to 3. So once you find x equal to 3, or the whatever, or this is length or whatever width, right? So you can figure out the volume. So volume would be just the length times width times the height. So volume will equal to 15. Okay, example 18-7 is an important problem. Okay, and it's a pretty neat tricks to help you to solve some of the problem that shows up in the math mean. Okay, so example 18-7 is given the area of the 3 faces of rectangular solid or box. Okay, so area of the 3 faces. And they are 24, 32, and 48. Okay. And finding the volume of the solid. Now, normally, if you don't know the trick, you have to do it by trial and error. It takes a long time. Okay. So, what you can do is you can write down x times y equal to 24. So that's your x and the y. Okay, and that means this will be a z. Okay, actually they have this reversed. Okay, they have x and they have the y over here and they have the x. Okay, so this would be the y according to the number. Okay, so xz equal to 32. So it doesn't matter which one is which. They're interchangeable. And yz equal to 48. So what you want to do is you want to multiply all this together. So you got xy. So the trick is to multiply all together and take the square root. Okay. So this will equal to 24, 32, and 48. So this will equal to xyz squared. And this one you can go and break it down into, so 24, break it down to the prime factorization, so it'll be 12, 6, 2, 3. Okay, so it'll be 2 to the 3 times 3. And 32 would be 2 to the 5. And 48 would be twice, just 2 times that. So it'd be 2 to the 4 and 3. Okay. So now when you take the square root, you're going to get xyz equal to square root of that. And that's your volume. See that? So you don't need to look for xyz by itself. Okay. So it'd be square root of, I'm going to combine all this together. So it'd be 2 to the 12, 3 to the 2. Okay. And so square root of that, so xyz would be equal to 2 to the 6 times 3. And so xyz would be 64 times 3 would give you 192. Okay. And that's it. So you don't even need to look for xyz. Now, in case if the problem asks you to find xyz, then once you find this, you can use this over here. Okay. So you can use this, divide by that. Okay. So xyz over xy equal to 192 over 24, and so this cancels out, so z will equal to, so in this case, get your calculator, z will equal to, I believe it's 8. Okay, so 192 divided by 24, yeah, it's 8. Okay. Now once you find 8, you can substitute into here too. I mean, you can use this divide by that to get y, use this divide by that to get x. But it's faster if once you find one of them, you can just use that to substitute. So x will equal to 4, and over here the y will equal to 6. Okay. So you can just use this. But the key is, the trick is multiply all this together and take the square root. Then it will give you the volume, give you the xyz. And once you get your xyz, you can go back and use it, divide by each one of these, and you can find each one of these individually. So this kind of problem shows up often, but you have different variations. Sometimes they ask you to find the volume, sometimes they ask you to find xyz.